Hello, it's me from the future. I'm editing part 2 right now, and this is like a little intermission. I have the feeling that I wasn't clear enough in the last part about how you have to model these modules. I've already mentioned that they have to be 1 meter by 1 meter. The last time I just took a cube and scaled it down by half. The standard Blender cube is 2 meters by 2 meters. So I also mentioned that I have to go into edit mode first. The geometry nodes tend to reset the scale of your object, and if I scale it down in object mode, well, it will pop back up to its original scale, unless, as I mentioned, you apply the scale, which you would do by hitting Control A, and with your object selected, just apply the scale. However, there's another part that I didn't mention, which is the origin of the object. If you would keep your origin in the center, your building overall at the end would stick half a meter into the floor, which is why I also tend to shift all my elements up half a meter. So the orange origin point is at the bottom center of your model. Now, these models that I showed you before are not exactly cubes, but they are just individual walls. You don't need to model the whole depth of the cube. You need to be sure that the origin relative to your model is still kept at this same spot. So when I model this wall, I might make it thin, but I make sure that the origin is not shifted. So as you would take a look at these models, you would see that the origin points are still kind of floating out in nothingness here, which is due to the fact that I did it exactly like I modeled this cube. You would also need to make sure that the individual parts next to each other will not leave any gaps, and in the most ideal circumstances loop flawlessly. You know, like if I would put an array modifier on it, it should work. If there are gaps in here in these modules, then there will be gaps in your building at the end. I hope this clears up potential questions, and now let's get back to the video. Using all that knowledge, we can now try to specifically address this very wall here instead of just some random ID stuff. So I'm going to get rid of the ID and rather take a look for input normal, which is the orientation where the face looks to. And if I plug in, no, wait a second, first I have to switch it over to vector. And now if I plug in the normal, we can, well, take a look at the individual orientation of each vertex. I'm going to set it to equal, and well, now we know that this wall is pointing in this direction here, and indicated by this green line, we know that this is the positive Y direction. So if I, in the Y point, plug in 1, we can now see that it returns all the faces that point in the Y direction. However, you might say now, well, not really though, right? It only returned the center ones. How is that? Well, the reason why that is that these points here are purely pointing the Y direction. All of that is fine and dandy. However, this point here, yeah, it might point to Y, but it also kind of points to Z. So it's more like a diagonal normal here. Just like these ones on the edges kind of point to Y, but also to negative X. So it's kind of diagonal in this direction. So they are not specifically precisely equal to 0, 1, 0. So that's why only these pure middle ones are returned. However, we can include them in this selection by just dragging up the epsilon value at around 0.71. At 0.71, the entire wall is selected. Now we have to do the same thing for every other wall as well. I know right now that I want all 4 orientations, so I'm going to make 3 copies of this. If I hold Control and Shift, it's going to maintain the connection to the normal if you have Node Wrangler enabled. And I don't even need to take a look at them. I just know that I am going to need the opposite of the Y, which is -1. I'm going to need the X, which will be 1, 0, 0. And I'm going to need -X, which will be -1, 0, 0. Those will be the 4 walls. Next up, I'll also need the roof, and I also want to address the bottom floor. However, those we will do a little bit different. Let me drag these down a little bit just to save them for later, and I'm going to make yet 2 more duplicates of the equal node. And first of all, let's start with roof. I'm going to plug this one in, which is going to be the roof. Plug in 0 here, and obviously I'll go into the z-axis and hit 1. Well, we cannot really see that anything happened. That is because the windows are not part of the floor here. You know what, I'm going to, instead of putting it in the switch, I'm going to put it in the selection, so it's just for now a little bit easier to see what I'm doing. So now I can see which parts I'm specifically addressing. And for this one, I'm going to lower the epsilon back down to something like 0.1 or whatever that value was. Because for the roof, I actually just want the middle parts. So now I also want the same thing for the floor. So I duplicate the roof one because it's already set up correctly. And I'm going to plug in -1 here and get the floor selection. I want to have the inverse of the floor selection. I want to select everything but the floor. And logic might tell you now that we can switch it from equal to not equal. But we get this. I have no idea why that is. My expectation would have been that we would just get the inverse of the selection, because surely the side parts and the roof are also not equal to 0, 0, -1. But maybe it's just a bug or I'm too stupid. So instead of just selecting non-equal, I'm just going to leave it at equal and search for Boolean math and set it to not. So equal not is apparently something different than not equal. Who knows? If someone can explain that to me in the comments, go ahead. I'm interested to hear where the logic behind that is. So I'm going to leave this plugin into selection because we have achieved precisely what we need, which is a cutout of the parts of the floor that will never be seen, that we do not need. I'm happy with that. And now let's get back to rotating. So just like last time, we're looking for a specific pattern of rotation, which is a side pointing in one direction plus including one of these corners for each individual part, which means that we will have to do some Boolean maths, which sounds more intimidating than it is. Really, essentially, we are just taking this selection of the bottom wall, and we're taking specifically this corner and, well, subtracting this corner from this selection. But that means that we are not only going to need a Boolean for each wall orientation, but we also need to be able to address each corner specifically. And that's what we will do now. But first of all, let's make it a little bit more apparent. I'm going to rotate it not by 90 degrees, but by 45 degrees, which will make it very clearly visible if we have selected something. And now let's start with our bottom 4 inputs here. So this is wall 1, this is wall 2, this is wall 3, and this is wall 4. So now how do we address a specific corner? A very easy way is to see where 2 walls overlap, like this one and that one. This corner is part of both. So we can use this Boolean math, set it to end, and tell Blender, well, take a look at every element that is part of this and this list, which will return only this corner. And well, now we just have to do this 4 times for every combination of 2 walls. Note, however, that, for example, if I would do something like this, it would return nothing. Now 1,000 points for the one who can tell me why that is. The reason is that these 2 walls are actually opposite of each other, which I can prove to you by just plugging it in here. So they actually have no part that even overlaps, so this one won't work. So rather we have to, for example, choose something like this one. So here we are now. We have 4 Boolean outputs that represent the entire walls. We have 4 Boolean outputs that represent the individual pillars on the corners. Now, how do we get this pattern of selection that I've mentioned before here in Photoshop? Well, I will show you. This end node as we've previously discovered, is kind of like an intersection, like an overlap. So if, for example, I would take my wall, which, remember, looks like this, and I want to overlap with something, how would this overlap need to look in order to return the kind of pattern that we want? Well, this other portion that we are going to overlap would have to include these 5 pillars, but specifically not that one, if that were to be the pillar that we want to exclude. How these look is completely irrelevant, as they are not selected in this boolean that we are looking at right now. So if this one is on or off doesn't really matter to us. The only thing that we want to specifically make sure is that this currently on boolean, as represented by the 45-degree shift, that this one is off. However, we only have this boolean that specifically targets that one, but it's on. So in order to achieve what we need, we just have to duplicate another boolean math node and set it to not, which is essentially just the inversion. And if I now overlap this thing with our straight wall, we get that, which is precisely what we desire. And yet again, as so often with this tutorial series, we have to do the same thing another 4 times. So with some trial and error, I have hopefully achieved what I want. This one has this one left out. This one has that one left out. That's a little bit confusing, right? This one has that one left out, and this one has that one left out. Great. Let me quickly switch these around so it's a little bit more in order. And this is some kind of node nonsense that I don't really need right now in my life. So I want to group them all together. When I group them, I will only get this and this output, which are currently connected. So I'm going to do a really quick and dirty little trick right now. I'm going to add a reroute node, make a couple of duplications of that, and connect all these outputs here. And if I now select all of these nodes minus the reroute nodes, if I hit Ctrl G and tab out of it, you can see that it has now created all the outputs that we need. In order for this to be useful at all, we obviously have to name those outputs, which is going to be a little bit annoying, so I'm going to save you the detail. The only thing I'm going to do is just go into this node group, connect one thing, and find out what it is. And because I know that I'm going to use this in the future, I actually also need an output that contains all 4 corners combined. We already do have the individual corners. No, here we already do have the individual corners, and we can get them all combined by, instead of using an AND node, which is kind of like an intersection, and switch it over to an OR node, which ironically is kind of more like an AND in the way you would think about it, because it adds together all the booleans that are set to on. So I'm kind of daisy chaining them here together in order to get enough inputs. So I'm just putting all the 4 AND booleans into one and just putting this here. And I'm going to call this output corners. And now, just to confirm my theory, if I put this in now, you can see we have something to specifically address the corners. So now that we've laid all the groundwork, let's reap in our rewards. Well, let's now quote-unquote daisy chain together some rotations. I'm going to make a couple duplicates so we have enough options available. So I'm just going to duplicate the switch and put it into the false input, and duplicate it again and put it into this false input. And now we have 1, 2, 3 different rotations that we can change, and one here that we can actually leave at 0, because, well, one of the sides will always be oriented in the correct way just by sake of logic. Well, now the only thing we have to do is connect up all the sides that we have. Let's quickly identify if I put in a rotation of 0 here. Yes, the positive x one is the one that is already correctly rotated, so we actually do not need to plug this one in. So I'm going to start with minus x, minus y here, and well, plus y here and minus y here. And the only thing that will be left will be the false input here, where we would have expected plus X. And as you can see, this one is now already rotated correctly. The only thing left to do now is just by trial and error see which side has to be rotated which way. This one would have to be rotated 180 degrees because it lies opposite of that 0 degrees. This one is this side. I'm always choosing the wrong side here, aren't I? This is 90 degrees. And the last one, by logic, has to be either minus 90 or 270. I think it's just what you prefer. And now we have rotated our building in the specific pattern that I ask you for in this Photoshop document. Sudden moment of aggression there. I don't know what came over me. So and now let's finally get rid of this ugly cube and let's find our brick building and let's now eyedrop the straight wall. Wonderful. Now everything looks marginally better. However, we do need to put in something different for the corners. Oh, and the bottom parts have reappeared because I've grouped them in here, but I didn't actually reconnect the bottom middle to the pick instance, no, to the selection input. So now the bottom is clean again. Yeah, you know what? Let's quickly replace the corners as well. Now we do have a problem. This switch situation is very neat, right? If I duplicate it, you might find that I can put in geometry in here, which gives me this nice green output. However, I can just tell you from experience that this will not work. I cannot give you the right argumentation why, if it is just a temporary thing or if it's intended, but there is a way that we can actually work it out rather than this method, which is instead of an instance using a collection. So what you do is you go into input and instead of object info you go to collection info. Now this thing here that I've built already I've put into a collection which is called brick building, which I will select here. And now plug this one into the instance. Now everything is going to go haywire. First of all, I will set it to relative and separate children. I will select pick instance, which are the steps, also reset children, which are the steps that I need to do, well, in order to set up the selection of individual parts. That was phrased very complicated. Just follow these steps for now. And if I put in a input integer here and plug it into instance index, now you will see as I toggle through these indices that the model changes, right? We put it to separate children because otherwise it would have tried to instance the entire collection as it is seen here instead of just an individual part. And we have selected reset children in order to account for them not being at the origin point of the world. And pick instances is the thing that we checked in order to have the ability to address a specific child of this collection with an integer. So I hope that clears things up a little. And now with this value we can actually use the switch. So let me duplicate this switch, set it from vector to integer, plug in the output. Let's delete this integer node that we had beforehand. And now we do already have a switch for what we need, which is this corners value that we smartly exposed beforehand. And now I can set different values for the center and for the corners. Those values correspond with the order of the individual parts of this collection. I have smartly named them from 0, 0 to 17. So we know that 0 would be the straight ground floor. If I select this thing that we need, we would see that it's 0, 3, and the corner would be 0, 4. So let's quickly put in 0, 3 into the false input. Well, just 3, we don't need 0, 3, and 4 into the true input. And voila, we do have this now. And you know what? Let's actually also put in the roof, because otherwise I would feel like this is like a bad point to leave this tutorial. So I'm going to duplicate the switch node. This time I'm going to plug in the roof middle into the switch. Now we have to think about this logically. We do not really care for the corners, so I'm going to plug it into the middle part. So here, the middle part. Now I have to set false, which is where we will not have a roof, to 3. And true, where we will have a roof, I will have to set to, let's check it out, 15. All right, that's a little bit complicated, but in the worst case, you can still get it with trial and error, right? It seems a little bit low now, but this is due to this roof edge that we have not yet implemented also being quite low. So don't worry, we don't have to shift anything up. Later on, it will all look better. But you know what? I think we have made solid progress. I guess we will leave it at this for now and continue this tutorial series in the next part, whenever that will be. We do have a building now that we can scale up in all 3 dimensions, and it works flawlessly so far. I hope you enjoyed it so far, and yeah, I just hope you are happy.